So let's get going with a practice period for our assignment for week 5. It's not a hard one. It's not a modeling task. It's more statistics plus metrics plus just some code wrangling in Python. And yeah, as both lectures previously, it has to do with object detection, namely with metrics that concern it, or mean average precision, something we looked at in the lecture. So yeah, here basically you do have only two files, which are map assignment ground truth CSV file and map assignment predictions. There are no images. It's easier this way to not make you even more confused if you have images, and less data to load in the system, of course. So ground truth, or GT, is just a file. It has we can try to download it and have a look what's inside. Wow, this recent update just isn't quite the hell. So see, inside the files is basically the first is like a header row or descriptors for your columns. There's a file name. The file name is called like xxxtus something something numbers GPG. This is just an image file, a unique and non-unique identifier, because on the same image there can be multiple boxes, of course. This is logical. And there's a class. Second column is a class. Do this a bit closer. So the second column is a class, and it involves just vehicles, I think. Probably not. Probably something else as well. Not so sure. We'll have to check it in the Jupyter. But then let's focus on these: xmin, x max, ymin, ymax. These are just coordinates of a minimal point and the maximal point. What's meant here is, I presume, if we go into Paint, we have this imaginary bounding box, right? And xmin, there are like 2 points, one here and one here. This point has xmin and ymin, right? This point has coordinate denotation of x max and y max. This is just to not get you too confused. And you can easily calculate the distance between like the width and height from here by subtracting this x max from x min, and subtracting y max from y min, getting these dimensions of the box, getting this dimension of the box, or just w, and get h. You might need to calculate center point, pink center point. Center point is just crossing two diagonals. Let me do this properly. 1, 2. Something like this. It's kind of the default notion of the data set. There's object ID as well. These are like these numbers: 0, 1. Let me zoom out. So this last element in each row is just an object ID in the same picture. So see this one picture. Oh, actually, this is a bit confusing. I'm going to clarify again. So presumably this thing has what? How many objects? 1, 2, 3, 4, 5, 6, 7, 9 objects, right? So it has unique numbers from 0 to 9 for object 0, 1, 2, 9. So this is the line 11 here is the final object in the same, oh no, line 10. Final object here. But the new picture starts GPG, but different numbers. These two are different. TUS 233, but some different timestamp. I don't know, this one. Then the object count continues. it just goes on to like 9. It doesn't restart like 0, 1, 2, 3 for the same inside the picture.
It's like a global ID basically.
Yeah, exactly. So we have to be mindful because I was taking a bit of time before I realized that when I was doing this assignment myself. So basically the format is pretty intuitive, especially when explained with these coordinates. Let's have a look at the other file, map assignments predictions. Let me see if I can do this in Excel. This is going to be better. This has the same thing, but it has. Let me do something very quickly. Yeah. So it has like this. Oh, this is perfect. This should have done this in the start. There's class vehicle, but also class human. I think there are 2 classes, maybe 3, maybe 4. 3. Oh yeah, human, vehicle, and object. So most objects here we have basically. How many rows do we have? Hello, 16,663. If we try to like, I don't know, we can do pivot tables, but I don't want to waste time on that. If I have a look at the humans, there are like 811 humans here in the recordings found. But if we have a look at the objects, it's like kind of something unusual. Only 209. So you have 3 classes. Obviously, the most important class kind of for the task is vehicle, but you will need to calculate like the second task before, like you do mAP, of course. Calculate AP for each class separately and divide by 3, and sum it up. Like divide by 3. And for this one, you need to build precision recall for each class. So how well does your model perform on separately on vehicles, on objects, and on humans? Once again, there's one new column here which is not present in the previous data set. Got the ground truth data set. Can you open? Yeah, there we go. So this is the same thing. I'll just open this not in Sublime but here. There we go. So this has like class and then coordinates and then object ID. And then if you go to predictions, it has an extra column called score. Score is basically how confident the model is this is a vehicle. This is like almost 100% confidence, like very, very confident. And here is like 92, slightly lower. Then there's 47%, 36, 23, 11 even. Like way not confident. Like this one, 0.08, absolutely trash bounding box, if you ask me. That's for you. Like if you want to like threshold somehow, of course. But maybe some of these are not worth looking into anything that's below like 0.8, right? Or 0.7. It's up to you. There are 4 coordinates, of course, and there's an index prediction ID. Let me see here. So this image, this is the same. Let me just outline this as a different color, some green one. So this 12 objects, 13 objects here are predicted on the first image. Some of them are obviously trash. I'll just show it up for you. These are very bad. These are kind of like decent. These are top tier. I think these cannot even be like considered bad. Like these should be blue. So these like middle zone. This maybe goes towards blue, I guess, but not quite that blue. This is kind of mediocre. So we have this different distribution of scores across one image, but of course you don't take this solely as one image. You extrapolate this on all the images in the data set here. So let's see. This is what 13, right? Yeah. So 13 here with this weird image name ending in 1036. In 1036 here we have less things, which also got me a bit confused last time. Let's also highlight this. So ground truth, these are ground truth. They only have 9 objects, meaning obviously some of these are false positives, right? Which ones? Yeah, well, I don't know. I actually don't have absolute clue which are false positives, but these are 9 objects that have a certainly decent number of confidence probability or a score. Maybe this is the distribution, maybe not. But you have to kind of like try to, when you filter, when you try to calculate your precision recall, you can do multiple things. Of course, you can calculate mAP on the whole data set first. Then you can build precision recall graphs per class. Once again, just on the whole, like thresholds. And in the third task, this is kind of a cool concept where you apply these thresholds and try to like improve precision recall, but just simply ruling out the unnecessary and extra bounding boxes with very low scores, like here, like these ones, or these ones for sure. And this goes for each class, for each image, etc., etc. So you have these kind of.
So for step 1, the threshold is 0, basically.
Sorry.
So for task 1, the threshold is 0. We consider all of them.
Yeah. It's just absent. You'll have to, this is like more for your own kind of like understanding and development as a professional, but you'll see what's the difference between like calculating mAP brute force, like head on without the threshold 0, or like setting it to like 70% or 80%, and then see how like precision recall change, because you probably will also plot the graphs. So this is a kind of like a creative task, but the minimum program is for you to just calculate mAP using any means available, either by hand or using any library, and then to plot the figures, or the like graphs of precision recall for each class, the ones mentioned here in lecture, these ones, sort of, I guess, or maybe not even these ones, but let's scroll up. What was that? Like this, maybe. Yeah, this looks even better, because you have like classes here, and they have these curves. You'll only have 3, and just to do something very similar to this would be absolutely great. Yeah, and last but not least, program minimum, of course, is just to try different thresholds and see how the precision recall react to that. If you increase the threshold, increase it even further, etc., etc. This is more like a creative task. Let's see how it's done. Kind of I can spotlight my kind of part of my solution for the previous year, namely for this mAP task calculation. So just load things in. I don't know. Hopefully, like all the libraries are here in this environment. How did this? Oh yeah, makes sense. So see, there's 16,000 predictions and only 13,000 countries. So some of these are false positives already. We can see that. And then kind of like you check things, see distributions of these classes, normalized ones. So humans are very little objects as well, whereas vehicles are like the majority of the data set. And this, yeah, you already went through the structure. What is this? Difficult crowd. Huh? Maybe there are some different files. DT alt. 1 sec. I check the image, of course. And then kind of you have to come up with the idea how to calculate these, either by hand or using some libraries. I don't know if this one works anymore, but it used to work. You calculate the whole like range for all the images, all the samples, using like default threshold or no threshold. At least should probably use 0.5, because 0 would be too bad. Because false negatives are better here than false positives, I guess. Maybe not. Maybe we need to think about like the cars dynamic in the roads to be able to see this to some plots, and pretty much nothing too out of the ordinary. This is just to be a draft. So Yeah, today we have it short. This was a kind of like a peek in the data, in the task. Pretty much, I did set up a deadline, but please do not be alarmed with deadline. Why is it 2021? That is weird. Let me just reassign that. Of course, take your time or any possible opportunity to dedicate like as much effort as possible to the task. 'Cause there's no rush. Why is this like this? I don't know. Anyway, so it should be fine. Yeah, that works. You just calculate mAP, build some graphs, and try to play around with thresholds. Any questions to that? To the home assignment lecture, additional queries. I don't think my illumination here is terrible. I'm sorry for that.
So questions about deadlines. I think deadlines for assignment 3 and 4 are also they also have 2021.
Yeah, I'll fix that. I know.
Yeah, okay.
You,
Also, a bit of a more personal question. So I kind of fell off a bit, and I've only done the first 2 assignments. Is it okay to still do the 3 and 4?
yeah, absolutely.
Okay.
I did like maybe I should have done the kind of the announcement
Mhm.
on part of like the general group, but I did talk to Lajal Carry there. Yeah, I did mention that it's absolutely not a big deal if you miss for some reason, like the deadline, or there was some kind of like circumstance that made you unable to actually upload or something. That's not a problem. Just make
Okay,
sure
okay.
you dedicate the time whenever you have it, when you feel like it, and like whenever everything is all right. But because we have like we live in a very rough times, I guess, and just don't prioritize this over anything else. And also, just kind of advice from myself, a personal kind of recommendation is not to put off everything till the very end, because when you want to like turn in all the assignments, it's going to be a bit too much of work to do. Perhaps not for every one of you. You said for the 3 and 2, right? Let me see. This one should be fine. So just upload. If you explicitly want to specify the reason why you were not able to do that, feel free to, but it's not also necessary. So no problem. Yeah. As per your projects, I hope you're doing at least some progress. The individual ones, I know the kind of organizational part of like me not putting things here like in the announcement of the course is kind of down, yeah, an overlook on my side, but we would want to see some certain like baselines on these group projects, namely what was that on these like tracks, at least one track of those, because like segmentation is taken, and the license plates, yeah, obviously something that Dr. Nadia would be very interested in, like seeing solutions to. But yeah, do take time to dedicate some of your time, and you'll probably be prompted to present some of these things, and but sort of like we can um, urge you immediately to like concentrate on it, because we know circumstances, and we know not like full concentration is possible right now, especially as a master's student, especially the second year. We all have like full-time jobs and stuff, so no worries there. But just a kind reminder, kind of that's it on this point. So yeah, from my side, I think that's it. There are no further questions as per lecture, object detection, or the home assignment here, home assignment number 5. Then I bid you a very pleasant Friday and great weekends, and please stay safe. Let me just stop the share. Yeah, see you guys in a week time. weeks.
Yeah, thank you. Thank you. Yeah. You too have a great weekend.
Yeah, bye bye.